Descriptive statistics for categorical variables such as vital status, sex, or cholesterol status, excuse me, are pretty simple because, as we discussed many times before, they cannot go on arithmetic operations. Again, we use three-pronged approach. First, we provide the frequency distribution, which is simply the count of each category within a variable. For example, say of 5,209 individuals, we had say 500 of them were smokers, and rest of them were non-smokers, or say 2,500 were males and 2,500 were females, and so on. Secondly, we provide the proportion or percentages of each of those categories within each variable. Again, simply speaking, say 49% males, 51% females, or say 21% of our cohort were having high cholesterol status, etc. And to complement those numbers, we provide some visuals. Bar charts are very popularly used in the descriptive statistics for categorical variables. The only difference between histograms and bar chart is that in case of histograms, all the bars are touching each other because they represent a certain binge, for example, 5 to 10, 10 to 15, 15 to 20. So in that case, we have all those bars touching each other. In case of bar chart itself, the bars are obviously separated from each other because each bar might be representing a category which is distinct from the other one, male or female, or smokers or non-smokers, etc. Pie charts are also a great way of demonstrating the proportions of each of those categories within each variable. Again, go to Task and Utilities, and then scroll down to the Statistics over here, and then Table Analysis right here. Okay, under Data tab, we have our data set already selected. In the row variables, let's choose only one for this purpose. If you see here, the options available are all the variables, both the continuous variables and the categorical variables. But if you remember, when we were running summary statistics, which is essentially for the continuous variables, it was only giving us the options for the continuous variables back then. But in case of categorical variables, it is providing us both the options. As you see on your screen, we have the categorical variables such as status, death cause, sex, cholesterol status here, and also the continuous variables such as age, chronic heart disease, diagnosis, age at start, etc. The thing is that SAS doesn't care. It will give you the frequency of even the continuous variables. But logically, it doesn't make any sense to run the frequencies of, for example, say age at start. It will give you the number of individuals who started at the age of 41, the number of individuals who started at 43, and the number of individuals who started at 45. It might be 1%, 2%, and there will be then say 50 categories, 100 categories. In our data set, it might be in thousands, and those will not give us any meaningful information, right? So anyways, coming back to the descriptive statistics for categorical variables, let's choose weight status. Okay, and we're going to leave the column variable for now. We'll use it in the next section. Move on to the Options tab. Okay, first uncheck chi-square statistics. We have not covered it yet. We will cover it in chapter 6. Choose percentages for the cells and percentages for the rows, and Yeah, that's all. In the plots, okay, we're gonna use, we want to run the plots. So let's submit the code. Okay. Okay, so here are our results. We see that of 5,209 individuals, 1,472, which is almost 28% of our cohort were having normal weight. When it comes to overweight, we see that a lot of individuals, 3,550 individuals, which is almost 68% or 70% of our whole whole data set of all our peer participants were overweight, and a very small number, only 181, 3.48, 3.45% of our cohort were underweight. And if you also look at the bar charts underneath, we see a very tall bar for the overweight individuals, modestly high normal weight individuals bar, and a very small bar for the underweight individuals. And here's the cumulative frequencies of all those categories. So what does it tell you? I mean, right off the bat, we see that almost two-thirds, more than two-thirds of our participants are overweight. Now, this is a very significant finding, and that is the purpose of descriptive statistics. We find such kinds of trends or patterns or some biases being seeping into our data set. Just imagine, this is a cardiovascular study. They might have put up their information maybe in the newspaper, maybe at public places they have put up some flyers or brochures, or maybe in certain clinics they have been putting up all those informations. Now, the individuals who are normal weight, or those individuals who are perfectly healthy, they are much less likely to enroll in the study. If you remember, when we were learning about Framingham Heart Study, it was a volunteer-based study. The people were volunteering for this study. So this is what we call the convenience sampling. It has inbuilt issue of these kinds of biases. The people who are likely to get benefit out of that study are more likely to enroll in that study. And we see it right up front over here. Overweight individuals are enrolling in thousands, almost more than two-thirds of our cohort are overweight individuals. And this is going to really bias our results. Not a huge problem if we acknowledge it, we understand it, we explain it during our analysis that we had this limitation hours in our study, and when we run our analysis, we look at our results through that lens, that our cohort may not be a perfect representation of the whole population of Framingham Heart Study. I can't believe that 70% of the population of Framingham Town were overweight. Okay, so again, this particularly is the kind of findings we expect during our descriptive statistics. If you are interested in learning the code to run descriptive statistics for categorical variables, it is again very simple. We call it proc freq from frequency. Let's open up our old program hot.sas, and the code is simply proc freq for frequency data equals FHS underscore lib dot hot. You can use any of them. Let's use hot and semicolon. Now, instead of variable, we use the prompt a table, because this step or this procedure is going to give us a table, and then we can use a weight status to run to plot a graph. The code is plot, sorry, plot, plots equals, in parentheses, frequency plot, open parentheses, frequency plot, close parentheses, semicolon, and we end up our step by the statement run. We highlight these codes and submit the code. Okay, so it is giving us almost the same results, in fact slightly more than that, which is better.